opted for a car in the upper range, convinced that even under future conditions, there'll be a continued need for this type of executive saloon car which combines comfort with economy. This research automobile incorporates innovative ideas, but for all its futuristic aspects, it's by no means intended as a mere exhibition piece, attracting admiration but serving no practical purpose. All the technical possibilities demonstrated in the research car are aimed at adapting the automobile to satisfy the increasingly complex requirements arising from the interface between man, machine, and the environment. Daimler-Benz is investing a great deal of time, money, and engineering effort in order to achieve further improvements in 3 different types of engine systems. One of these, the 3.3-litre V6 diesel engine, made in lightweight metal, operates on the pre-combustion chamber principle. The advantages: high efficiency, especially at part load, and low exhaust emission level. Twin inline exhaust turbochargers that ensure rapid gas intake and high torque even at low revs. To reduce the noise level, the engine is fully enclosed and has automatic transmission. The second system is a refined V8 petrol engine. The higher part load consumption of the V8 compared with the diesel is reduced by a series of energy-conserving measures. A load-controlled cylinder shutoff, for example, permits easy change from 8 to 6 or 4-cylinder operation. In 4-cylinder operation, the engine consumes less fuel at full throttle than it does at part load in 8-cylinder operation. And in the 4-cylinder mode, it retains all the comfort of the V8 engine. R&D efforts are also geared to development of a Mercedes-Benz gas turbine, the first in the research car project. This achieves a working temperature of 1,250 degrees centigrade, prerequisite for low fuel consumption. High temperatures like this can only be attained by using ceramic materials, as here, for example, for the turbine impellers. The gas turbine can operate with different types of fuel. It combines favorable torque characteristics with low wear and vibration-free operation, simple ignition system, and good cold start properties with low exhaust emission. All 3 drive systems are coupled to 4-gear automatic transmission. This transmission gives the driver a button-touch choice of 3 different driving programs: fast, economy, and city. The major criteria in the development of the body shell were wind resistance, safety, and lightweight construction. The aerodynamics were optimized by improving design details. Sloping wedge-shaped front with aerodynamic apron. Flat roof, cam rear end, rear spoilers, bonded windows recessed into the outer paneling. These measures reduce wind resistance compared with that of the S-Class Mercedes by a further 20%, giving a drag coefficient of below 0.3. Despite greater safety and more comfort, further weight was saved by the use of lighter materials. Aluminium was used, for example, for the engine, doors, and bonnet. Weight was also reduced by newly developed plastic components, like this universal joint shaft made from carbon fiber reinforced plastic. High priority was given to further improvements in safety. Accident statistics have shown that at the front, the impact is more likely to occur on the left side of the car. so this part of the front section was reinforced, for example by stiffening the bonnet and hinging it down the left-hand side. An extremely rigid seat frame was installed to permit all 3 points of the seat belt to be integrated in the front seat. The doors were reinforced to provide better protection in side collisions. To protect pedestrians and cyclists, the entire front of the car is designed to crumple on impact. Foam padding, for example, is fitted to the bumpers and the wings are collapsible. Another safety feature is the low front apron. Linings on the window pillars and the elimination of sharp projecting edges from the roof diminish the risk of injury and accidents.